Good morning, students. Today we'll be talking about solving systems of equations as a review. So we're going to hit one equation and we're going to solve it by elimination, then we'll solve it by substitution, and then we'll graph it out to see if we did in fact solve it properly. So we're going to start out with elimination. Now once again by review, elimination is the concept of using the two equations with each other in order to eliminate or remove one of the variables. So looking at this equation here, I have an x and a 2x. I have a negative 5y, a negative 7y, 17, and 22. Now if I look at this right off the bat, I'm not really seeing anything that I can eliminate right away. But what if I were to multiply this top equation by the number 2? Technically, you can do that because whatever you do to one side, you have to do to the other, but I'm really not changing the value of the equation. And for example, if I have a little scale here, and this scale is holding a bag of rocks, and I don't know how many is in each bag. I don't know how many is in each bag, but I do know that I'm going to double the amount on this side, and I'm going to double the amount on this side. The weight will still be the same. So let's do that. We're going to take this equation, we're going to move it down over, let's put it down here. So I'm going to say 2 times x minus 5y equals 2 times 17. So I'm going to distribute this 2 onto both sides of the equation. Once again, I'm going to multiply this 17 by 2. So this is the same as 2x minus 10y equals 2 times 17, which is calculated by as 34. So now I have this first equation, which is the same thing as up here. So let's rewrite the system of equations again. So we have the system of 2x minus 10y equals 34. And then we'll write the second equation down here. We don't need to do anything to that. 2x minus 7y equals 22. So you look at this equation, now there's something that we can eliminate. What we can do is we can begin to say, hey, if I add, or I should say if I subtract this bottom equation from the top equation, I will eliminate a variable. So let's do that. 2 minus 2x is going to be 0x. Negative 10 minus negative 7 is a negative 3. Negative 3y. Now careful with your negatives here, because that can be a little bit confusing for people. And 34 minus 22 equals 12. So we've successfully eliminated the variable x, and now we just have to solve for y. So let's divide both sides by 3. We'll divide both sides by 3, and y equals negative 4. So now we have to go back into the original equation and say, well, if y equals negative 4, what does x equal? And we only need one of the equations to do this. So let's use the first one. So I'm going to say x minus 5 times negative 4 equals 17. So I'm saying x plus 20 equals 17. Well, let's subtract 20 from both sides. That will leave me with x equals negative 3. So the solution for this equation is going to be, by elimination, is going to be x equals negative 3, y equals negative 4. So now we're going to solve the same equation, but we're going to use substitution instead. So let's see, let's use tan. So I'm going to take the equation x minus 5y equals 17, and I'm going to rewrite the second equation, 2x minus 7y equals 22. So the goal for substitution is to see if I can get x or y alone on one side, and then plug the opposite side into the equation. So I'm going to use the first equation so we can erase the second one for now. So I have x minus 5y equals 17, and x looks pretty happy alone. I bet I can make x alone. So I'm going to say x, I'm going to say, I'm going to add 5 to both sides, 5y. So let's add 5y to both sides. 5y, 5y, and this will equal x equals 17 plus 5y. So now I know what x equals. I mean, I don't exactly know the number, but I know whatever x is, it's 17 plus 5y. So what we're going to do is we're going to take the second equation now, which is 2x minus 7y equals 22. And we're going to plug in this value for x in for x. So let's do that right now. 2 times x, but we're going to say, oh, remember x equals 17 plus 5y. Let's take away 7y, and that's going to equal 22. So we're distributing these two pieces of information out here. We have 2 times 17 is 34, plus 2 times 5y is 10y, minus 7y, and this equals 22. We're combining like terms, we get 34. Oh, I'm going off the screen. We're going to go up here. So combining like terms, I have 34 plus 3y equals 22. So let's subtract the 34 from both sides. And I get 3y equals 22 minus 34, and that will get me negative 12. Divide both sides by 3, and I have y equals negative 4. And you look and you say, hey, that's the y I got here. And you plug the y into the original equation once again, which we did in the first step, and you realize, hey, they're the same thing. So it'll save you some trouble if you can figure out, hey, I do not know which is easier. Should I eliminate or substitution? They both are legitimate means of making the equation work. So now we're going to take a look and see what we can do to graph this equation. So let's build our table, and we're going to build an equation to graph this equation. So taking a look at this equation, you could say, hey, I have first to change both of these into slope-intercept form. So let's change that really quickly. We have x minus 5y equals 17. I'm going to add 5 to both sides. X equals 5y plus 17. Subtract 17 from both sides. X minus 17 equals 5y. And finally, I divide both sides by 5 to get my final equation is x minus 17. Let me put that right. Let's see, where should I put that? X minus 17 over 5 equals y. So I'll put that here. X minus 17 over 5 equals y. And our second equation, let's write it up here, is going to be the same thing as 2x minus 7y equals 22. I'm going to subtract and add oppositely, so it's 22 minus 2x minus 22 equals 7y. Divide both sides by 7, and it's 2x minus 22 equals 7. I'm sorry, divided by 7 equals y. So we have our two equations here, and we're now going to solve the line for these two equations. So if x equals 0, because it's always a nice thing to start with 0. If x equals 0, looks like y equals 0. Why? Oh, no, it doesn't actually. My bad. Here we go. If x equals 0, y equals negative 17 over 5. Just for fun, let's put in x equals 17 here. If x equals 17, this will equal 0 because 17 minus 17 is 0. 0 divided by 5 is 0. Therefore, 17 and 0. So now we have the x and the y-intercept. So that's kind of handy. So let's go on to the next point, and we'll see if x equals, let's make x equal 11 here. If x equals 11, 11 minus times 2 is 22, minus 22 divided by 7 is 0. Great. So we have the intercepts there. And then we also have, I think I changed the color for this one so that we can identify them. So if x equals 0, then we'll get negative 22 over 7. So now we can chart out these 2 points. So the first one, I have 0 and negative 22 over 7, which is pretty much the same as 3.1, negative 3.1. So I'm going to go 0, negative 3.1 right here. And then my second point is when x equals 11, so that might be somewhere out here, y equals 0. So you can actually plot that and you can say, hey, oops, that didn't work. There. So the line is going to be something like this. So now we'll go back to our first equation and say, well, negative 17 over 5 is pretty much the same thing as negative 3.4, which is just a little bit bigger than this. So when x equals 0, it equals negative 3.4. And the second part, when x equals 17, which is right here-ish, when x equals 17, y equals 0. So we'll draw something like that. Oh wait, you know what? Something more like this. So if you look at these 2 lines, they're not going to intersect in the general area over that direction, which is going off the chart, but that's okay. It's not going to intersect down that way anyways, because you can see the trajectory. What they will do is they will intersect, they will intersect from down this way, because the line continues that way, and the line continues that way. So they'll intersect down here, which if you do the math and see above, you can start to say that, hey, this point at which they intersect is negative 3, negative 4. And you're looking at the quadrant, and this is a double negative quadrant, so yeah, that looks like it's reasonable. So the next part that we're going to take a look at is mixture and motion problems. Now, I believe I already have a video on mixture and motion problems, so I'd recommend that you stop and take a look at those videos for some more information on how to do a mixture problem and how to do a motion problem. That being said, a quick summary of a motion problem is related to the equation distance equals rate times time. And a mixture problem is going to be something related to the equation of maybe the percent equation, which would be, or the basic percent equation, which is percent times the whole equals the part. And you'll be taking 2 pieces of known information, so x1, which will be one color, and x2, which will be another one, and filling in pieces of information that you know in order to solve it. So once again, please refer to that video for more information. And finally, solving systems with inequalities. When it comes to an inequality, they're actually very similar to solving a system of linear equations. The only difference is you'll have an inequality sign instead of an equal sign. So you'll still have to change it to slope-intercept form, which is fine, but then you have to interpret this as the inequality sign as well. And interpreting it as the inequality sign will say, hey, 0 is greater than or equal to negative 17. So for the green line, let's change the color here. See if I can get some kind of soft color. That's perfect. Perfect. So we'll get 0 is bigger than negative 7 over here. So you can actually say that this whole area here is highlighted for the green, and the area that's highlighted for the yellow will be something like the places where they intersect with each other. Oops, the yellow line doesn't go. It doesn't go along the yellow line. That is a place where the inequalities are solved for each other.